Welcome to our presentation, Error Detection and Correction, presented by Urmi, Nasima, Rizvi, Farhana, Faisal.
Greetings everyone, I am Mohammad Ashraf Faisal. My ID is 2411538. Before starting the presentation, I'd like to thank our respected Jayadul Alam sir for giving us the opportunity to discuss on a topic of immense significance in today's presentation. So today we are here to talk about error detection and correction. So in this presentation, we will understand why error occurs in data communication, identify the different type of error, explain the basic error detection, then we will describe error correction, and then compare the correction and detection, and the last one is real life implementation. So we need to understand for that what is data communication. Data communication means transferring data from one device to another by using any communicating device, and error is error is basically when we sending the data, the original data is transferring due to some noise or interfere, it is changed, that is called the error. And error detection is detecting the process, finding the where is the main data is corrected. And the last one is error correction. So after finding the data where is incorrect, then we need to fix it and correct that data without resending. Basically there are two major tasks. One is data error detection and error correction. Now I will describe error type of error. Basically there are three type of error. Basically there are many types of error. Single bit error, basically there is just single bit is when we are sending any data, there is just, if there is one mistake, if there one bit is changed, that is called single bit error. And burst is more than one bit, if it is changed, then we call it burst error. Packet error, basically when we send the data, and if now we are coming back to the redundancy. So what is it? Extra bit added to the data to detect or correct the errors. And there are different types like parity check, Hamming code, then Jones checksum, then with this CRC cycle redundancy check. Now I will describe parity check. So what is it? Parity check is an error detection method where an extra bit is added to make the total number of on if it is even or odd. Basically, there are two types of parity check, like odd and even. If the total number of one, what is sending we, as a sender, if I send any number like 5 digit, and if total number is 1, total number of 1, if that is odd, then the last digit what we are sending, that must be 0, because already there is odd. But if that is even number of data we already calculated that we sent, then we also needed to add 1 for this for total number is odd, to make total number is odd. So basically the same way as even, if the total number of 1 in the sender, then we if total number is 1 for the sender, then we don't need anything to add. Last bit must be 0. If the total number is even, odd, then we must be the last digit what we are sending, that must be 1 to make sure that is even. So that's all from my side. Now I'd like to invite my next team member to discuss about this presentation. Thank you.
Thank you, Faisal. Assalamualaikum sir. My name is Fahim Shahriar Rizvi. My ID is 241156110. Now I'm talking about forward having code, error detection and correction. What is having code? Having code is an error detecting and error correcting method. This code is invented by Richard Hamming. Example: data is 1011. Now I'm talking about encoding working method. Step 1: determine number of parity bits using formula. The formula is 2 to the power q greater than is equal to k plus q plus 1. Here k means number of data bits, q means number of parity bits, n means number of code word bits. When we put the value of q is equal to 3, then we get 8 greater than is equal to 8, which is valid. Data is 1011. Step 2: place parity bit at position. We can see some positions, and the parity bits is number of parity bits is 3 because of q is equal to 3. Here parity bits are R1, R2, R3. We put R1, R2, R3 at position 1 to 4 because 2 to the power 1, 2 to the power 0 is equal to 1, 2 to the power 1 is equal to 2, and 2 to the power 2 is equal to 4. Step 3: draw table. We write R1, R2, R3 right to left, and also draw here min-term table 0, 1, 2, 3, 4, 5, 6, 7, and write the binary value of 1, 0, 1, 2, 3, 4, 5, 6, 7. Step 4: place parity bit at position or take the place number where there is an 1. R1 is equal to 1, 3, 5, 7, R2 is equal to 2, 3, 6, 7, R3 is equal to 4, 5, 6, 7. Step 5: calculate the parity bit using even parity or odd parity. Here I use even parity. R1's parity is 1, R2's parity is 0, R3's parity is 0. We neglect R1, R2, R3. Send the code word, and the code word is 1010101. Send the code word to receiver. Decoding: receive the code from the sender. Here 6 position is 1, that is changed. Step 6: receiver check the parity bit to detect error. Check even parity again. R1's parity is 0, R2's parity is 1, R3's parity is 1. When all the value of parity will 0, error will not be detected. When all the value of parity bits are not is equal to 0, even error will be detected. Here error will be detected because here all value are not 0. Step 7: locate and correct the single bit if any error. We write R1, R2, R3 at the position of right to left and with binary value, and the binary value is 110, and the decimal value of binary 110 is 6. So there is an error in the position of 6, and correction of 6th position is 0. Having distance is the number of bit position in which two binary string of equal length differ. Encoding: we can see some data and code word. Let's send the code to receiver 10011. Receive the code from sender 10111. Here in 3rd position the data is changed. Decoding: step 1: matching data with default code word. If match, there is no error, but here the data is not matched with code word, default code word, so error detected. Step 2: find having distance with code word by using XOR operation. Here code word, upper side is code word and downside is received data, and first one's distance is 4 because there are 4 1 in answer, and second one's having distance is 2, third one's 1, and fourth one's 2. Take minimum distance is 1, and the code word is 10011, and the correction is 10. If there are 2 or more having distance with same receiver, send the message to sender, send the message again. Error detection possible having distance -1, and error correction possible having distance -1/2, and answer in floor value. Thank you. Now I invite my next partner.
Assalamualaikum. I'm Nurmi. My ID is 241-15492. I'm the third member of our group, and I will be explaining CRC cyclic redundancy check. In my part, I will show how CRC actually works using both binary and polynomial examples from our slide. So what is CRC? CRC stands for cyclic redundancy check. It is a technique used to detect errors in transmitted data. CRC works by dividing the data using a generator and the remainder of the data. Division is used for error checking. Now I will move to the first example of CRC encoding. CRC encoding binary calculation. In this slide, we are given data word 101101, generator 1101. The generator has 4 bits, so we add 3 zeros to the data. This forms the new data becomes 1011010000. Next, we perform binary division between the extended data and the generator. After completing all the division steps, we get remainder 010. So the final CRC code word becomes 1011010110. Now let's move to the next slide where we send and receive this code word. Sending and receiving the code word. In this slide, we see the code word being sent to the receiver. The sender transmitted 10110110. The receiver accepts the same bits. Now at the receiver side, we apply the send generator 1101 to divide the received code word. Let's go to the next slide to see whether an error is detected or not. Next, we move to the polynomial version of CRC, which uses algebra instead of bits. CRC encoding polynomial method. In this slide, data polynomial x to the power 3 plus 1, generator polynomial x to the power 3 plus x plus 1. Here we will follow some steps. Step 1. Multiplying the data by x to the power 3, shift in left by 3 degrees. This gives us a new polynomial to divide it. Step 2. Divide the shifted data by the generator polynomial. After the division, the remainder we get is x square plus x. So the final code word becomes x to the power 6 plus x to the power 3 plus x square plus x. Let's go to the final slide where the receiver checks for errors. Polynomial CRC decoding. At the receiver side, the same generator polynomial divides the receiver code word. This time the remainder is 0. A remainder of 0 means no error was detected and the data is considered valid. Thus, we can say CRC uses division to detect errors. The sender sends data to remainder. The receiver divides again to check the remainder. If remainder is 0, we will find error. If remainder is not 0, we will find error. CRC is widely used because it is simple, fast, and very effective in communication system. That's all from my session. Thank you.
Hello everyone, Assalamualaikum. My name is Miss Nasima Khatun. My ID is /340. Today I will presenting my presentation. My presentation topic name is checksum. So what is checksum? A checksum is a small value used to detect errors in transmitted data by comparing the sender's and receiver's calculated values. Algorithm of checksum. Sender calculates a small value from the data. Receiver recalculates the checksum. If both checksum is matches, then no error detected. If they don't matches, error is detected. For example, the data word is 1000111. Then the step 1 is divided data. Split the data into fixed size blocks like 4 bits or 8 bits. Here is our data word, and we have split our data, then 0 1 1 0 0 0 1 1 1. Then we add all blocks, perform binary addition of all data blocks if there is a carry or up around. Then we get our value is 1 0 1 1. Then we take 1's complement for this value, flip all bits of the checksum 0 to 1 and 1 to 0. So we get 0 1 0 0, 1's complement, or this is our checksum. Here is our code blocks, data word plus checksum. Here is our code word. Then when receiver receive the code word from the sender is 1 1 0 1 1 1 0 1 1 1 0 1 0 0. Receiver calculates this value, and receiver adding these 3 blocks. Then receiver gets the 1 0 0 1 1. Here is 1 is carry, so 1 is wrapped again, and this value is 0 0 1 1. Then takes 1's complement, or flip all bits of the sum 0 to 1 1 to 0, and this result is our checksum. If 1's complement is equal all 0, then error not detected. If 1's complement is not all 0, error detected. So here is error detected. Then when receiver gets when data word is decimal value 4 8 10 7 5, then the step 1 is sum of the data and find binary of the sum. Then 34 is the sum of this data word, and we have calculate the binary value, decimal to binary value. Then we added our data. Then takes 1's complement, or flip all bits of the sum 0 to 1 and 1 to 0. Then we gets our checksum is 1 0 1 1. Then decimal value is here is the decimal value is 11. So the code word is 4 8 10 7 5 and 11. Then receiver receive the code word from the sender is 4 8 10 7 5 11, and sum of the receiver receive this data and sum of the data and finding binary of the sum is 45. Then he calculate this value decimal to binary, and so on. Take 1's complement 0 0 0. Here is the result is the sum of the receivers, the checksum is 0 0. So 1's complement all 0, so data not error detected. And if 1's complement is all not 0, so error is detected. So here is error not detected. Here is the end of my topic, and thank you.